Let's take a look at this payback scenario. Okay, the first question, you see it right there, this paragraph here to the right of my mouse, or maybe I'll move it over here to the left of my mouse. Demonstrate how you could calculate payback if the initial cost of a course of action, or a project actually, was 150 million and the positive cash flows per year that resulted would be 40 million per year for 10 years. All right, let's just tackle the first one. I put the numbers here. And the way you calculate that, it's very simple. When you have constant positive cash flows in all future years, let me delete that. What you do is you would take the amount of the cash outflow, and I'm taking it as an absolute value. You can see I've used ABS, that's the absolute value. So take the absolute value of cell C15. You can either look down here at the formula or up here. Appears in both places in Excel. And divide it by the positive cash flows for the future years. Okay, so if you put that in, hit enter, you get 3.75. Very simple. Okay, and that formula will work when the cash flows are constant, and we see all of these are 40 million per year. So the cash flows are constant. The payback is 3.75. That's in years, 3.75 years. Okay, now to the right, or excuse me, the left of my mouse. Next, demonstrate how you could calculate payback if the initial cash flow was 150 million, so the same amount, and the positive cash flows per year that resulted would be 40 million per year for the first year, and then the positive cash flow is expected to increase by 7 million per year for the next 10 years. All right, well, first, let's assume that you interpret this to mean that the positive cash flows go from 40 million to 47 and then remain constant. You know, it says it's expected to increase by 7 million per year for the next 10 years. If you interpret that to be it just increases once and then holds constant, here's how we would calculate that. Now, what you can see I did here is here's what I'm doing. I'm saying, well, we know there's 1 year in the whole, 50 minus 40, and then we have 110 left. So I say, well, we know payback is 1 year, and then you can take the 150 minus 40, which gives you 110, and divide it by the 47, right? Now, if you wanted to actually type that out using the cell references, you would type equal 1. Again, you can look down here or up here, and then you would say plus, in parentheses, we're going to take cell D15 minus cell D16, and then we divide that by the next constant amount, 47. Okay, now came out a little bit different. Because that amount is negative, we need to put the absolute value in there. I'll show you a couple different ways to do this. You could put absolute value in there and come up with it. Or if you wanted to even make this simpler, just take the first number as a negative amount. So you'd say 1 plus a negative D15, right? And then you don't get rid of that. And then you say D15 minus D16. So negative minus a positive. That same answer as soon as I put this in correctly. That would be minus. Okay, so you could do it the negative or the absolute value. I actually prefer using the absolute value, so let me Control Z. I'll put it back. Control Z just removes what you already did. All right, so in English rather than Excel terminology, we know 150 minus 40 gives us 110, and we're in the whole 110, so that's 1 year. And then you would take the constant dollar amount of positive cash flows divided by the remaining amount. So you would simply take the 110 divided by 47, and you could calculate this first scenario that way. Now, if you didn't want to do it that way, and this is the way I typically do this, I calculate a cumulative cash flow. So if we look at this, we're 110 in the hole, right? C15 plus D16. Then I take the cumulative amount from the cell above, add 47, and it keeps going smaller and smaller till we're positive. So then what you can do is you can look ahead and you can say, well, we're negative 3 years, so I know we're 3 years in the hole, plus a fraction of the year. So the fraction of the year is the 16 negative at the end of year 3, and we're going positive 47 during year 4. You can see where I'm pulling the numbers from. So if I do that, I get that fraction of the year, and that's 3.34. Okay, now if instead you interpreted this problem as it increases by 7 million every year, then your only way is to use the cumulative approach. So now we've got different values, but it's essentially the same approach. We know we're negative 3 years, right? 3 separate rows. The period is a year, by the way. Okay, and then we're negative in the whole 9, and we're going to be 61 positive in the next year. So if I take that 9 divided by 61 and I take that negative and turn it into an absolute value, meaning a positive number, I get the proper amount of the fraction. Okay, so that's how you would tackle payback scenario for scenario 1 and scenario 2, depending on how you interpreted what it was asking.